Assalamualaikum warahmatullahi wabarakatuh. My name is Aiman Bin Noor Zelan. I am postgraduate of the Master of Science Electrical Engineering and my program code is CEE750. So today I will be presenting the progress report for my semester 2, which is on semester of September 2023. So before I start, I will introduce my supervisor, which my main supervisor is Associate Prof. Dr. Muhammad Nabil Hidayat, and my co-supervisor, Technologist Dr. Aiman Bin Noor. So after the DRP, uh, below the title, which is the design of the original DC-DC converter will govern isolation between DC charger and energy storage system. So under the research description, as you can see on my slide, they have three problem statement, follow up with the three objectives. So they have some methodology that have two phases, which are the software development and hardware development, that related with the three outcome, which is the outcome is related with the main three objectives. So for that, I will just briefly background the study for the why I'm doing the bidirectional research. So before that, I will need to tell that about 80% of the greenhouse gas emissions we are produced by the air pollution is too high, and the international transport data shows that it still produces the 24% of the global CO2 emission from fuel combustion. So while in Malaysia, the transportation sector consumes 35% of the total energy, with vehicle contributing significantly. The EVs are the solution for the cleaner air and efficient transportation. Malaysia aims for the environment sustainability percentage of 38% in the market by share by 2040 through the low carbon nation aspiration. And the increasing our energy efficient bidirectional charging infrastructure are prominent in the EV charging system. So they have the two type of the bidirectional charger, bidirectional converter, which is the non-isolated and also the isolated converter. So what's the comparison is the non-isolated more efficient, smaller and lighter, while the insulated one is provide the government isolation, which is the government isolation ability ensure safety, adaptability, and potent matching. So the study focus on the designing and implementing EVDC topology, which is the isolated bidirectional DC converter. So the problem statement that we get is which the converter itself, the non-isolated DC converter, is lack of safety feature, resulting in the potential failure and potential stability for the converter. That's why uh, the research is focusing on the isolated one that have the governing isolation. Governing isolation, it can prevent the failure and the potential stability for the converter. So the next problem statement is for the isolation PDCs, switching on is occur due to the hard switching. So the solution is on the using the number circuit, so it can be the soft switching of for the computer. Third problem statement is the lack of information in regards parameter isolated by the schedule computer that integrate with DC charger and energy storage system. So on the literature review, we show that there is uh, there is a low lack of information on the parameter itself, especially for the bidirectional converter that integrate with the DC charger and energy storage system. So the objective, uh, they have three objectives, which is the bidirectional DC converter with the solution plays an essential role in improving the safety operation of the equipment. To the effect, the objective of the study is first is to design the bidirectional converter topology with current installation. Second, to enhance the soft switching technology by adding this number circuit. And third, to verify the validate workability of the isolated bidirectional converter topology, which include the integration of the decision and the user system. The objective, uh, the objective come out how depends on the problem set. And the scope of study, you can analyze uh, the impact of the government solution or the system efficiency, safety, performance, and also for the integral part of the design implement of the request number system for the enhancement. So the key outcomes measure model of recovery related BDCs, number effectiveness. The hardware implementation is get great the functionality of the cases. And the detailed recommendation of the governing solution, effect, the benefit, and limitation. So the result will be the comprehensive organical with transformation and case. The contribution of the research is on the advanced governing solution PC for the CCJ ESS integration, and is aimed to provide a holistic insight into design performance and challenges to simulation and how. There are four things that limit of the study, which is the non-ideal components, the temperature effects, component degradation, and also lastly the operation condition. So the significant study is to examine the energetical problems involving EV chargers and power electronic system from the material equipment design, construction to the application. So introducing VDC with governance installation as a power electronic device will provide the ability to deliver more efficiently and effectively transmit and receive power with separation for an exchanger to ESS with the grid. Lastly, to ensure safe operation, enhance the system efficiency and dependability, and boost the competitive reliability. So this study is a paramount significant for several reasons. One of them is the addressing the operation need, advancing BC technology, ensuring safety with governance installation, enhancing system reliability, particularly implementation and analysis. So there's one of the literature review related with the isolation disease converter from the type of the converter, which is push pull forward DB. I'm choosing the push pull because they have some advantage, which is the shift switching and less stage reliability for transfer. So they also have the advantage of parameters help input side cost and side increase with increasing overheating. So the conclusion the efficiency is high, the modest width density is moderate, componentization capacity is more. But why I'm choosing the push pull because we integrate with the ESS, so the AV, so ESS need low voltage and stability to avoid from uh, the battery become degradation. That's why I'm choosing the push pull converter. So for the controller, they have also have a three type from the studies. Choosing the BI controller, maybe it depends on the control. So the BI controller is better because the efficiency if time long, so it's the error is the immediate state and has the advantage of the simple structure, convenient use, and also good stability characteristic. So the number circuit for my DC converter is I'm using the passive, which is here. It has the two type of number which is passive and active. So from the comparison, I'm using the passive RC because it's a simple and cost effective. Generally suitable for the low frequency application, minimal additional physical complexity. So conclusion is for the why using this number is that actually the both passive and active numbers are used to mitigate for the smart in electronic system. So the choice between them depends on the larger application requirement, the capacity of the solution of the level of the precision needed and the available budget. So the method, which is methodology, we can separate into two types, which is the single phase and the second phase. Which is the first phase is the software development, and second phase is the hardware development to develop the PDC. So they have causation theory framework. The principle in design, what I'm choosing is the full bridge push pull bidirectional DC converter. So it consists of four switches at the primary side and also two switches at the secondary side. So they have some inductor at the secondary and also uh, capacitor at the primary and also at the secondary side. So this is one of the mathematical relation of the voltage and current in the steady state, which we have the IDC, the duty cycle of the current inductor divided by the number of turns, number of ratio turns. So this is one of the theories for the full bridge push converter. So as you can see, for the controller, also they have some conclusion. So as you can see on the G CV side is focusing on the bulk mode, and GFP is focusing on the boost mode, which is bulk mode target main focus on the charging to the ESS. For the boost mode, focusing on the discharging from ESS to EVs. So this is a framework simulation from the MATLAB. As you can see, I developed the full bridge push pull converter on the by operation of the bidirectional, but I add up the buck boost converter at the primary side to control to control the forward uh, backward power flow, which is we can conclude uh, charge from ESS to EV, EV to ESS is depend on the flow of the current itself. So for the bulk mode, the charge mode for this version, we're starting try to report that to using the to show the potential difference, which is if the EV side is higher than the ESS side, so the battery will be discharged. And then from EV we charge to ESS. So same goes concept with the boost mode and the discharge mode, which if ESS is higher voltage than the EV side, the ESS battery will charge the EV side battery. So this is my bar chart, which is currently I'm still follow the track and according to plan. So for the semester two, I'm using for the semester two on the January 2024. Mean the software solution been developed the complete model system by adding the steps. So the milestone is to complete up the estimation, which already complete the estimation, but there are some controller need to be studies on how to control without using the bulk boost converter at the primary cells. So there are some studies and also some research to be made for this research. So the plan for the next semester three is actually to develop the hardware development. But before we proceed with the hardware development, I want for the research, I mean my research is focusing the simulation. I mean the controller, how to control efficient. I mean to control based on uh, the theory the theory formula for the controller, which is on the bottom. So after get 100% good result on the controller, so we proceed with the hardware development. So on the status of publication, so as you can see, we have some paper has been published at the IB Science, which is the title of the paper is the submission of some investigation into the charge performance of the lithium ion lead acid battery electrical vehicle. So so it has already published, and this is one of the publication paper that we so currently the status of the thesis writing, introduction, the review on the methodology still in the for the abstract 40%, introduction 60%, literature review 60%, research method 60%, and the results still not yet there. And also the commission. So this is maybe we will be made on the next semester. So these are one of the reference I made for the interview. Thank you very much. See, the end of presentation. Thank